Hi, my name is Jeff, and I'm here to explain how Legend of the Black Skies is designed to handle more than 10,000 players at once, as well as some other really cool features in the game that sets it apart. See, Legend of the Black Skies is a 4X adventure game, and there's a lot of 4X adventure games like EVE Online and whatnot that have really massive, epic battles. But when you have too many players in a small amount of space, what ends up happening is the battle starts slowing down and you get degraded tick rates. And if you look at all the Guinness Book of World Records holders, they have different types of failures. And I don't believe any of them has passed a battle with more than 10,000 players yet. But if you look at things like Discord and Netflix and Uber, they can handle more than 10,000 users at once, no problem. Similarly, you look at the universe, and there's a lot going on there too. So how do we take the learnings from Discord and make a game, or all of big tech, should I say, and make a game that feels like I'm inside a universe that doesn't fall apart? And one of the key things we need to look at is what we call CP versus AP. And let me explain what that means by an example. So we're in this massive battle, and your ship destroys my ship. So we have a server. But that server, if we want to scale infinitely, you can't have a machine that's infinitely large. So what we do is we have multiple machines that talk to each other. So your ship might be on this server, my ship might be on that server. But then these servers stop talking to each other. So we could do one of two things. One, in the case like my ship's about to blow up, we can wait from both of the servers to go talk to each other again, or a broken server to come back online, and we continue where we left off. Obviously, that has some issues about having to wait, especially if the servers disconnect and the things that are on the server are not related to me. That does make for a good gameplay experience. But so does playing for a while and being told, by the way, your ship blew up 2 minutes ago. We just found out. All right. Now we look at how the universe works. Now, the universe, if the sun goes out in 6 minutes and a few minutes or a few seconds or whatever the time is, I will eventually know that the sun is out. But from my perspective, it's not. So a good way to establish that is saying, from a gameplay perspective, we need we need to feel like the things around us are happening immediately, but things not around us can be eventually consistent. And then you have like outliers like spooky action at a distance. So like, let's say, and this is a real thing with quantum computers. Computers can do this now with Hadamard gates and stuff like that. So let's say you have this particle over here, and this other particle is super far away. And this particle gets modified a little faster than the speed of light. That doesn't mean information happens. So if I look at this particle and I say, "Hey, what's the state of this particle right now?" or I collapse. Anyhow, I I see, yeah, it looks like this, but I can't interpret it without having information from the thing it's paired with, sending it to me to decode it. So even when things seem to happen faster than light, we have this constraint about data does not travel faster than light. Okay, so how does that translate to Legend of the Black Skies? Well, the first thing we do, we have this hex tile. This hex tile has a bunch of cells on it that can represent ships and all that jazz. And there's cells, there's hexagonal cells inside that tile because it's a tactical game or a strategic game. And each ship can only occupy one cell, can only have one entity, be a ship, an asteroid, or if I'm on a space station, a player, something like that. So now we have a bounded maximum amount of things we have. We don't have to worry about physics collisions or anything like that from the level of scale that we had before. So this is a lot easier to calculate. And also, there's a maximum amount of things that can happen in the tile. That means that a fully saturated tile, meaning like if there's something in every single cell, has a maximum number of things that are there. And how things can do things is, let's say I'm a player on a space station, I have 7 energy units, and if I want and when I make an action, I use something against one of those energy units. Let's say I move. It's 2 seconds to drain one of these energy units. So come back. I do something special and I make the sentry gun. That may be a minute for this energy unit. And so that makes for good gameplay. So that means like standard stuff that happens quickly, don't really slow down. And if there's something powerful, I have to make tactical decisions and risk versus reward and all that. But from a mechanical perspective, that means that if all players do the maximum amount of things possible in the same amount of time, there's still a cap, and that can be calculated. And now a tile isn't an island unto itself. It's got things surrounding it. So these tiles, they it feels like real time to the user, but really have half a second turns essentially, where they have half a second to process everything that happens. And each one of the tile has their own half a second turns. So, which really means that the communication between myself and the surrounding tiles has to happen in a way that it feels seamless to the user when I cross around tiles. Just like the universe, the further away things are, the little more stale they are. But from my perspective, everything still seems real. And that also, and if you want more like crossing boundaries between tiles, there's technical blogs about that on Jeffrey.blog that explain it in great detail. But from a high level perspective, now we have the system that fans out. The further I get, the more stale the data is. But there's some gotchas, and there's a lot of gotchas, but we'll get over those. So let's say, so the universe, even in the void, that is a thing. But in a game, we're not going to simulate the entire universe in empty space, because that's, why would we have a tile where there's nothing in it? But at the same time, I want to be able to travel through empty space as much as I want to be able to go inside this massively dense packed, action-packed place. So we have something called garbage collection, which means that if a tile has no permanent entities in any of its cells, considered an inactive tile. And each active tile has connections to all of its neighbors, but inactive tiles do not. So that means that once a tile becomes inactive and it has no incoming connections, it garbage collects itself. So it basically says, I have no more reason to exist. It deletes itself. So how is a tile created, right? Because I talked about before about the universe being relative to everybody's perspective. And if we have a manager that's in charge of all the tiles, that creates the same type of scaling issue with AP versus CP that I talked about before. So we have a bunch of tiles over here. And let's say I want to warp into this place. But this place doesn't exist. So I need to create a new tile. So, and I'm here. So what I do is I start in a spiral pattern from like the most zoomed out view, saying there's a neighboring tile over here. It's the closest tile in a spiral pattern. So I keep on zooming in and zooming in and zooming in to say like this exact cell is the cell in this resolution of like where the closest neighbor is. So now you have a million people talking to this guy saying, I want you to spawn this for me because it's your job. And again, everything's bounded. And again, so like the external constraints are 10,000 players at once, but internally we're looking for 1 million. So that we know we can handle everything. And it can just say like, I'm already creating the tile, and everybody else in the queue would say like, yeah, I already got this, we're good. And then it can continue with that. But if you remember, actually we can keep that for now. Everything is relative to my perspective. So I might say, from my perspective, this is the closest tile. You might say, from your perspective, this is the closest tile. So I'll ask him to create a new tile, and you'll ask him to create a new tile, and he'll create this guy, and I'll create this guy in exactly the same place. So that's what we call a race condition. And we solve that by something called epochs and sharding and concurrent hash maps. But from a simple perspective is, you went first, you create a tile like a nanosecond first, and there's ways to handle ties that are outside the scope of this. They're all on the blog. So you have ID 1, and then I have ID 2. So when that tile says like, okay, I'm going to send this information to the player instead of persistent storage, my tile will have ID 1, and it'll say okay, and then your tile writes I have ID 2, says okay. And then my tile tries to write again, and it's like, hold on, you're obsolete. Because tile 2 is the most recent epoch, the most recent tile. And there's remediation of it when there's edge cases and stuff like that, again, on the blog. But from a high level, what happens is from a life cycle perspective, tile 1 says, is told by the database, no, I'm not writing for you because you're too old, and this is who replaced you. So the old tile will say, okay, now I will tell everybody connected to me. Don't connect to me, I'm old. Connect to version 2. They'll disconnect, my neighbors will disconnect, and then garbage collection will happen. So the still tile will go away. And there's details about how edge cases and all these matrix of race conditions work, on the blog or other sources. Long story short is now we're able to create new things without having to worry about the scalability limitation, because every single part of the system is worried about eventual consistency versus strong consistency. What should stay strongly consistent, and we need to keep that narrowly scoped and conceptually sharded to a tile. There could be multiple parts of the system that's all conceptually sharded to a tile, but as long as that's done across the board, what that does is it basically lets us simulate the universe in a mesh that feels like it's real time, with the delays that are the same type of delays that the real world has anyways. And through this design, there's a bunch of fun stuff that happen as emergent properties. For example, the NPCs, from the system's perspective, exist in the same layer of the pipeline as where the players are. So you have like all this backend stuff here, and you have what we call a gateway, and then we have the user client. This is the NPC client, so give me the information. Here's my update. And why that's cool is a few reasons. First, the way NPCs work are the same as looking at a deck of cards. So let's say you have an NPC that is trying to strong. And so an NPC that's trying to gather resources. This is a living world, and he's hired by some company. He gather resources to sell to some corporation to go through the supply chain so a station can build a widget. So what the NPC does is the deck of cards. The first one is gather resources for the thing. Do I have enough of all these components? Yes, yes, yes. Oh, there's a component I don't have. I need to gather that. So my next turn, I say switch decks would be the result of that card. And the next step would say well, am I close enough to do a thing for that deck? No, for that mineral, because I'm in a different sector of space. And the next card would say something like, well, can I warp? Do I know where it is? And can I warp there? And if so, warp there. And it keeps on shading like that. And because they're so simple, they're not even state machines. They're just looking at card decks, essentially. We can have thousands and thousands of NPCs. And we tested this. And it takes way, way less than our budget for half a second. And they're also sharded in a way that we can scale. It can continue. It's not bound to a tile. You can look at the tech blog for the details, but essentially we can have as many NPCs running as we want without negatively impacting the system. Okay, that also means as a result, you can have henchmen or whatever that act in a certain way, or your guild or your crew can act in a certain way. You can even have AI systems. For example, let's say that I'm in a dogfight and I know there's some tactics that I want to do for my guns. I could activate an AI that only controls my guns, where I control the movement of my ship. And I can go offline, for example, and then when I go offline, I can say well, I don't like grinding, or I don't like fighting, or I want to patrol this area, or I want to explore, I want to run these missions. So you can focus on the things that are fun when you're playing, but your player becomes an NPC when you're gone, and the actions are controlled by your deck. And this creates another emergent property, which makes the game, this living world, even more fun. So we have things called monitoring with the 3 pillars of observability, which is another thing I'm not going to go into. But from the perspective of these talks, is that we have an AI looking at very large scale and small scale events. For example, let's say there's a caravan of 500 NPCs with mercenaries protecting all these haulers to try and mine resources, and the players say, let's go mug them. Well, that would impact the supply chain. And that would change how the game works, or there could be an exploit that's going on. So all these aggregations and summaries are sent to a game master, or what we call a warden. And they'd look at all these summaries and the AI. So like, here's our suggested results. So you could either do that or choose what happens. So which keeps the gameplay fair for everybody and also lets the plot organically grow based upon how the players act. Because there's still a human controlling all the long-term things and reacting. So the game feels less procedural, even though it's heavily procedural, but it's procedural, but it's guided by an actual human. And if the human wants to make something that's not an existing gameplay mechanic, we move to our main program, Plot Warden, which is the real big tech of Cogni Cluster, which is the umbrella company, which is essentially an orchestrator of building things. And the way Plot Warden works is you have what are the features that you want in the game? Like, what are the things that should exist? And based upon that, what is the architecture that we should have to make that happen? Then we have what is the architecture that currently exists, and our knowledge sources, which is a little bit of a tangent, so I'm not going to go into that. And then we have, well, we're currently building things because we're constantly building things, so really old things in flight. For example, let's say crew morale gets impacted after a battle, and the warden might say, you know what, I think it would be better if morale is happening in real time. So it would add that feature, and then it would redo the way that the intended architecture should look. And then it would look at the delta between the current architecture and the intended architecture. And the things in flight, which are scaling out like a tree as well. And it'll say like, okay, well, what's in flight that is useful for this? And what's in flight is not useful for this. What's in flight based upon old data, which is obsolete, and all that jazz. And basically reconciliates everything like an aircraft traffic controller. And what ends up that meaning is when a warden wants to make a new gameplay mechanic to respond to what's going on in the players, they can do that easily as a GM, and the AI will come in and incorporate that gameplay mechanic because that's already how Black Skies is being built. And for a technical perspective of Plot Warden, you can go to ambientagents.next or look at Jeffrey blog/writing and see a lot of technical details of how that works as well. But it all comes together into an interactive, living, massively scaled world. Please look at the articles if you want additional information.